All right. So now we're looking at histograms. And like I said, if we look at it, we might say, oh, yes, that's a bar graph. But there's certain things that are different. Number one, there's no spaces between the bars, right? And that's because a histogram is a bar graph, or a histogram displays continuous data as opposed to discrete data. So each bar represents a range of values, not just one value, okay? So a big thing is that histogram, the bars are going to be right next to each other. So that's your big difference. If the bar has space, if the bars have space between them, we're dealing with a bar graph. If there's no space and we're dealing with a range of value, then we have a histogram. So that is our biggest difference with these, okay? So histograms, no space between the bars because we're dealing with continuous data. In a histogram, categories are adjacent, side by side, with no gap in between. And they depict ranges of values, not just one value. So here we have our first example. The number of apartments sold in Vancouver in September 2019. So we have our title. We have our title on our axes. And on our axes, we have the price, and it's in thousands of dollars. And what we notice is that it's a range. So houses that were between 100 and 200, between 200 and 300, between 300 and 400, 4 and 5, 5 and 6, 6 and 7. And then we have the number of units sold. So when it asks, why is a histogram used to display this data? Well, the price or money is continuous. And it's a range of values. So within this 200, 300, you could have a house that was sold for $210,000, or one that sold for $275,000, or one that sold for $2,058,000. They would all be part of that second bar. Okay, what trends appear in the histogram? Well, number one, the highest number sold is between $300,000 and $400,000. There's not a lot sold comparatively between 100 and 200,000, or 600 to 700,000. So that's what we notice. We also notice there's none less than 100,000. So the lowest price house or apartment sold in Vancouver was 100,000. Okay. What was the price range of the, let's see, most number of units sold? So the most number of units sold, as we indicated in that last question, was 300 to 400,000. And the least number, well, the least is 600 to 700,000. Okay? So, or you could say it's actually 0 to 100,000, because none were sold, right? This is none. I would take both, okay? How many units sold for between 200,000 and 300,000? Well, if we look at our thing, 2 and 300, it's about what? Would we say about 420 to 425? And how many sold for exactly 250,000? Can we tell that? No, some of you may be saying, oh, just take the middle there, miss. But that's not right. We want to know exactly. A histogram won't tell you exactly. We do not have the information. We don't know how many of those 200 to 300 houses are exactly 250,000. Okay, so that's an important thing to know about histograms. It's not going to be precise in that way. Okay, alrighty, so let's look at another piece of information. So we have some information here. A new company, Acme Inc., is trying to decide whether or not to reimburse employees for their daily commutes. The company wants to analyze the varying distances people travel to see who qualifies for reimbursement. The following data represents the distances that employees travel. And using this data, we want to construct a histogram to represent each group. So let's look at this data, and we're going to have 4 bars or groups to represent the data. Now, the largest value we have when we look all the way through all of this information is 40. That's our biggest number. Our smallest value is, if we look through, is 2. So our largest value is 40, smallest value is 2. So the range is 40 minus 2, which equals 38. Okay, now we're going to round up to make sure all of our values are included, but this will give us an idea of the width of each group. So if we go 40 minus 2, and we want 4 bars, we're going to have 38 divided by 4, which is 9.5. I would round that to 10. Okay, and then that way we'll be sure that everything is counted. So let's look at our data and let's do a tally. So if we're going from 1 to 10, 11 to 20, 21 to 30, this is our range of 10, 31 to 40. And we're going to do tallies. Now, I'm looking at the list of information on my screen. You guys can see that hopefully on your paper, so you can follow my tallies as I do this. Okay, so looking at my data, 1, because the 5 goes there, 12 goes here, 11 goes here, 27 goes here, 6, 18, 22, 13, 31, 20, remember on your 5th one you cross it, 16, 9, now I'm on the 2nd row, 14, 18, 22, 30, 33, 11, 8, 14, 25, 21, 16, 11, 19, I'm going to run out of room there, 19, 14, 24, 28, 13, 8, 6, 2, 22, 31, 40, 23, 4, 26, 30, 22, 17, 15, 18, 8, 31, 12, 19, and 7. Okay, hopefully I did that right. I'll know in a minute. So here I have 10, 5, 10. Here I have 20, 5, 10, 15, 20. Here I have 13, and I have 5. Woo! Okay, now we have all of our data kind of tallied. Now we have to build our histogram. So we're going to take that data and we're going to build our histogram. We have to remember our graphing rules. So the bars touch. right? And each bar is a range. I want a title. So bars touch, this is different from bar graphs. This is a histogram, right? So daily commute distance of employees. Okay. And then on the bottom, we're going to have travel distance. And we're going to have our number of employees. Okay. Now, total number of employees, the biggest group I have for traveling, if I look here, is 20. And so I'm going to go up by 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I'm lucky, it works. This first bar is going to be 1 to 10, right? And they touch. This next bar will be 11 to 20. And I've just chosen to make them 3 wide. You might choose to make them 4 wide. Then we're going to have 21 to 30. And then finally, 31 to 40. Now, 1 to 10, when we looked at that, it was 10 employees, right? Okay. 11 to 20, it was 20 employees. And again, you should use a ruler. Mrs. Finley is not, but you should. 21 to 30, we have 13. So halfway between those. And then we have 5 for the people who live a far distance away. You might choose to shade them in if you want, just to make it look pretty. So I'm shading these in. But we can tell from this already what the trend is. The graph is it tells us a lot more pictorially than just a list of numbers do, right? It really gives us an idea of how far away the bulk of our employees live, okay? I did forget one thing here. This is in kilometers, okay? We want to make sure we have our units. So it says how many people travel 30 kilometers or less. So that's 30 is the top part here. So that means we're going to add that row, which is 15, plus the 11 to 20, which is 20, plus the 10, which is 1 to 10. And we will get 15 plus 20 plus 10. Okay, 45. Now, if Acme agreed to pay a travel stipend to those traveling 21 kilometers or more, how many people will they have to pay the travel stipend to? So we would look at the ones that are 21 or more. We know it's these last 2 columns. So it's going to be 15, or sorry, that is not 15, that's 13. Let me double check my math. 13. Mrs. Finley, read your graph properly. So this should say 13. So that means our total will be 43. Sorry. So let's fix this as well. Okay, so it'll be 13 plus 5, which is 18. Okay, now if they had said how many people are we giving the stipend to if it's 25 kilometers or more, we can't tell from this bar graph, or this histogram, sorry, because the ranges mean that we can't tell where the number of 25 and greater are. We'd have to change what we made for our ranges if that was the answer. So we can only really tell those windows. So sometimes it's important to know the questions we're going to be asked about the data before we arrange it. We want to arrange it in a way that's going to be useful for answering our questions. Example number 3. Examine the smallest largest value range and width of each bar if we were to make histograms for the data sets below. So we're going to take a look at these data sets and make some decisions about what kinds of ranges we would make on our histograms if we were building one. So looking at this data set here, we want the smallest value, which is 0. And then as we scroll through, I've got an 11, I've got a 12. So the largest value is 12. So the range is 12 minus 0, which is 12. Number of groups I'm going to use is 3. So the width will be 12 divided by 3, which is equal to 4. So my groups are going to be 0 to 3, 4 to 7. Oh, this is number of groups. So if each one is 12, I do have a 0 though, right? So would it be 0 to 4? I know this is going to end at 12. 8, 9, 10, 11. So it's going to be 9 to 12, and this is 5 to 8. That one column is a little misleading because it starts at 0, but it's the best way to do it because you'll have 4, the range of 4, right? Looking at the data for here, we have the smallest value is, okay, I've got a 55, a 54, a 45, and a 45. So 45 is my smallest value. Okay, I got an 85, an 85, a 92, and 92 is my largest value. So 92 minus 45 gives us a range of 47, and I want 5 groups. Now, so 47 divided by 5 equals 9.4. So I would round to 10. Okay. So my ranges are going to be 0 to 10, 11 to 20, 21 to 20, or to 30, sorry, 31 to, never mind, I'm going to redo this because I have to think about what my smallest is. I'm doing my range here. So my smallest value is 45. So if I go 41 to 50, 51 to 60, 61 to 70, 71 to 80, I'm not going to get there. 81 to 9. I'm going to have to start at 45, which is fine. I can do that. So, starting again. 45 to 54, 55 to 64, 65 to 74, 75 to 84, and then 85 to 94. And that will include our smallest value and our largest value. Okay, just barely on either side. So it's a little tricky. As you noticed, even for me, I had to try some different things. For some reason, I was trying to put it starting from 0. I think you just have to kind of acknowledge that on your graph. Okay. All right, now you've got some practice to do. Practicing with histograms. Pay careful attention to how they're different from bar graphs.